Yes, we will go with another problem, Thevenin's theorem. Calculate IL value, calculate load current value using Thevenin theorem. This is our original circuit. Now the points AB is in the center, AB is in the center. Load current IL is present. This is the load, capacitor is the load, minus 5J. Minus 5J is the capacitor load. Now, this is the Thevenin equivalent circuit. Across AB, we have to calculate V Thevenin, R Thevenin, which means we should not disturb the AB path. We should not disturb the AB path. The remaining full circuit, we have to convert it into single voltage and single resistance. Remaining circuit, we have to convert it into single voltage, single resistance. Okay. Now, in the circuit, we have one voltage source, one current source. Voltage source is 50 volts, current source is 20 amperes. So, we have these two. The rules are, we have to make voltage source active, current source inactive. For the first time, calculate VThevenin. Second time, keep current source active, voltage source inactive, and then calculate VThevenin once again. Okay. This is the first case. I am keeping current source active. Voltage source inactive means I am putting it open circuit. Across AB, I have to calculate VThevenin. Okay. There is no closed path, so no current is flowing. No voltage drop in 5 ohms and 5 ohms resistor. So when we see across AB points, the voltage available is 50 volts only. This is case 1, VThevenin value 50 volts. Case 1, VThevenin value 50 volts. Okay. Now, case 2, we are making current source active. We are making current source active, voltage source inactive. Voltage source inactive means we are making it short circuit. Voltage source inactive means we are making it short circuit. And then across AB, we have to calculate VThevenin. And current source, we are putting it active condition. So there is a closed path. Current will flow in this direction, closed path. So the voltage here is 5 into 20, which is 100 volts. 5 into 20, which is 100 volts. And the same current will flow in this 5 ohms also. Here also 100 volts. Okay. But we are calculating across this AB points. And hence, you can see here current 20 ampere flows across AB means the voltage here is 20 into 500 volts. Second case, it is 100 volts. And the first case, Thevenin voltage is 50 volts. So total Thevenin voltage becomes 50 plus 100, which is 150 volts. 50 plus 100, total V Thevenin becomes 150 volts. Now R Thevenin calculation. R Thevenin calculation. We have to put all the sources inactive. Voltage source short circuit, current source in open circuit. Then we have to calculate resistance across AB points. That is the rule. Now you can see this is the circuit. Current source inactive means open circuit. Voltage source inactive means short circuit. Across AB, we are calculating R Thevenin. Okay. So when we look at here, only this 5 ohms is present. So 5 ohms is the R Thevenin value. And V Thevenin we got 150. R Thevenin we got 5. All the complete circuit across AB path, we have made into single voltage and single resistance. And that is 150 and 5. Now AB points, we have a capacitor that we replaced as it is. AB points, we have a capacitor that we replaced as it is. Only this AB path, we replaced as it is. Remaining all the circuit, remaining entire circuit, we converted into single voltage, single resistance, that is Thevenin equivalent. Okay. Now, we are calculating this IL value. This is a closed loop. This is a closed loop. When we apply KVL, this V Thevenin and current is flowing from left to right, minus 5 into IL. And here also current is flowing at the minus sign, minus J5. Okay, minus J5 into IL. I forgot writing IL here, into IL. Now, you make IL as subject, we will get V Thevenin divided by 5 minus J5. V Thevenin divided by 5 minus J5. Okay, this is IL value. And here for rationalization, what we can do, numerator and denominator, we can multiply with 5 plus J5, 5 plus J5. Okay, V Thevenin value is 150. V Thevenin value is 150 divided by 5 minus J5 is there. Rationalization, we are multiplying numerator and denominator with 5 plus J5. Okay, so denominator becomes A plus JB, A minus JB, which becomes A square minus JB whole square. Okay, J square is minus 1. J value square root minus 1. J square value is -1. So minus into minus will become plus. A square plus B square is the value. Denominator A square, 5 into 5, 25. And again here, plus J5 minus J5, it becomes plus 25. Numerator, we will have 150 into 5 plus J5. So 150 by 50 will become 3. 150 by 50 will become 3. 3 into 5 plus J5, which becomes 15 plus J15. 15 plus J15. Okay. This is the current value. Amperes is the units. Amperes is the units. Here, how we got 5 minus J5? The resistance is real part. Impedance is imaginary, complex value. Impedance is complex value. So this Z is nothing but R plus JX. R is resistance and X is due to capacitor or inductor. Imaginary part is due to capacitor or inductor. This is called reactance. Okay. Resistance plus reactance is called impedance. Resistance plus reactance is called impedance. And it is of the form A plus JB. When we calculate magnitude, it is square root of A square plus B square. This imaginary part will come due to either inductor or capacitor. If it is capacitor, we will have minus JXC. Where in our problems we came across minus J5. So due to capacitor only, we got this minus J5. If it is inductor, we will get plus JXN. Okay, capacitor means minus JXC. Inductor means plus JXN. This is the imaginary part in Z value. Okay, so this is just rough for discussion we have taken. With this second problem, we completed and the answer is 15 plus J15 amperes.